Welcome to our talk. It's called Kubernetes is too complex for startups. Wrong. Okay, so why this talk? Well, how many times have you heard someone say, Kubernetes is only for the enterprise. Kubernetes is simply too complex. We can always migrate to Kubernetes later. Kubernetes is actually not right for us. We don't need that kind of flexibility. We're special. Our product is simple. But if your product is simple, that's because it's still a prototype, right? Because building a business is complex, and making software is complex. And you, that's all of us here, will have to deal with that complexity, right? So the question is, how do you choose the right technology to handle growing complexity? Well, you choose modern but boring technologies. Boring technology is a term we've borrowed from Dan McKinley's excellent essay of the same name. Okay, so what's a boring technology? Well, boring technologies are well-known, mature, and have both wide community and industry support. Choosing mature technologies makes it easier to do the thing you want to do, because someone else has already done it, so you don't need to reinvent the wheel, right? Makes it easier to debug, makes it easier to hire for, because you can find someone who actually knows what the damn thing is, right? Makes it easier to find documentation, because someone might have written about it on Stack Overflow. Maybe your LLM even knows about it, and so on, right? Don't risk experimental technologies, make the safe choice. Another concept we've borrowed from Dan's essay is the concept of innovation tokens. The idea is that you have so many tokens. Every time you do something complex, you spend your tokens. So the point, of course, is spend your tokens on what matters, which is the business, not on fighting unnecessary complexity. So a rhetorical question, what does dating apps and energy trading have in common? Well, both requires lots of software, and making software is complex. This talk is based on our experience dealing with complexity, using Kubernetes in startups in two very different fields, and they are respectively the dating app Double and the energy trading company Green.ai. My name is Xander. I've been 2 years at Green.ai. My title is Head of Software Platform. That means I do software, like build the platform and write the software that runs on the platform. Before that, I did consulting and teaching about everything Kubernetes, DevOps, and Cloud Native, part of the Cloud Native Copenhagen organizer team, and I run Kubernetes for fun in my home lab, so make of that what you will. And with me, I have Dag.
Thank you so much. My name is Dag, and I work for Egmont in the platform engineering team. And as you probably know, Egmont is not a startup. Egmont owns around 140 companies across Europe. So I was, as Sander said, talk about my previous workplace, which was Double. And when I was there, we were only 6 people, and I was the main person responsible for all infrastructure, cloud stuff like that. And the only reason you may not have heard about Double, that's because you're not 20 years old. Because if you were, you would definitely have tried the app, or at least know a friend that is on the app. It's fairly popular in that age range. And it's a dating app that focuses on double dating, meeting people in small groups, and more social aspect of dating. And with that said, I will now tell you about the time when I joined Double, because these guys invited me out for a job interview, and they already knew I was very much into the whole Kubernetes ecosystem thing, so they could probably guess that I was going to ask them, so are you using Kubernetes? And they answered something along the line of, well, we're just running a few containerized applications. We don't really need Kubernetes, and we don't even plan to have any new one coming up anytime soon, so we don't need this scalability. And I was like, that makes sense, I guess. Maybe they're right. Maybe Kubernetes is not the right solution to every problem. Like, maybe I'm this guy that runs around with a Kubernetes hammer, so all I can see is nails. Or maybe I just go to too many of these conferences where all we do is pat each other on the back and tell each other how much we love Kubernetes, right? Maybe there's another solution for this. And so Double, we're using a tool called AWS Fargate, and don't worry, I did not know what that was either when I joined, but it's basically just this serverless compute engine thing where you can run containers and AWS take care of the rest. For the sake of this talk, you can see it as the same as the normal ECS service, Cloud Run Container Apps, container instances, whatever serverless tool you know from your favorite cloud provider. All the arguments we use during this talk applies to all of the cloud providers. But they're basically sold on this idea that they're easy to get started with, easy to work with, and you don't need to worry about the underlying orchestration and so on. So I signed a contract, super excited to get started, get to learn something new, and I need to figure out if this Fargate thing is the promised land of simplicity that is much better for startups. So one of the first things I do is, of course, I want to open up the code, see how do we define our workload. And then I open it up and I see, of course, we're defining an image, we're defining a variable, environment variables, loading in secrets, CPU and memory and so on. But there's actually more. You also need to care about service discovery and what kind of ports and paths are open and health checks and set that up. And then I also need to do something with rollout strategy and auto-scaling policies and so on. And it's like, okay, that wasn't that simple, right? And also, this kind of reminds me of something, right? Oh yeah, it reminds me of Kubernetes, because it's basically the same thing you do in Kubernetes, but it's not exactly the same, so you cannot just like reuse your Kubernetes knowledge. I kind of need to remap all that knowledge into AWS Fargate terms and abstraction and so on, and there goes a lot of my innovation tokens. I have to spend time on actually, reusing my knowledge in the Fargate way here, and with very little benefit. So my first realization is that declaring workload is not simpler when you're using serverless solutions like, for example, Fargate. But okay, I can survive that. One of the next steps is that I want to get an overview of what are we actually running at double. So I want to see a diagram. And these guys showed me like a diagram of 50 different boxes with 50 different lines between them and connecting services and all this kind of stuff. And first of all, like, I'm very impressed that such a small team can actually run all this stuff. This is not the real image, by the way, but you get the point. And I'm thinking to myself, like, okay, sure, we're only running a few containerized services, because that's because the rest of the logic required to run this business is scattered across the full ecosystem of something else. And I was like, how does this happen? Because I have been to many companies that are much larger, but have less moving parts. So how does this even happen? And that's probably because, like, if you pick something, a serverless solution like Fargate to begin with, then you are super happy for the first 3 days. And then you realize, I also need to do some data processing at night or something. I need to process something. So you start adding Lambda to your stack. And then a few days later, you realize I also need maybe some kind of caching layer to my Fargate service so I can respond to request quicker. So you add Elasticache. And then a few days later again, maybe next week, you need to pass some data between Fargate and Lambda, so you have like some temporary storage on the S3. Point being here is, before you have even launched your product and gotten your first customers, you're already 5 to 10 products deep into the whole ecosystem of AWS. And it quickly just feels like a big spider web of interconnected services that is very difficult as a startup to actually get an overview of. And don't get me wrong, like, many of these tools may be simple on their own, but all the complexity comes from when you start combining them and different interfaces and so on. So you really need to keep this in mind. And no, this is not just because these guys designed it poorly. These are smart people, but this kind of architecture is just a natural consequence when you're picking these easy-to-use serverless solutions. Because if you start off with Fargate, for example, every time you hit a limitation, well, the natural next step is always to progress further into that ecosystem and go down that path. Just like if you went with Kubernetes, well, the natural next thing, and we know, is to go into the CNCF world or open source world or whatever and go down that path. You can, of course, pick whatever path you want here, but you can probably imagine that the further down you go one path, the more expensive it's going to be if you want to switch at a later point. So my second realization is that starting with these serverless solutions, like Fargate, for example, have very strong implications on your overall architecture. As you can hear, so far I'm not super impressed with these serverless solutions. That was my initial assessment. Now the real work begins. I actually need to solve some business problems for Double. And one of the first things that come up is this idea of A/B testing. And that's because when you're building a dating app, one of the most important aspects is actually the algorithm that figures out which profiles should be shown to which people in order for people to actually have a good experience and get matches and so on. And if you accidentally make this algorithm worse, well, then people immediately are going to stop using your app. So it's very important that whenever you make changes to this algorithm, you only test it on a smaller sample size and then roll it out gradually to the rest of them. This requires a kind of complex or advanced rollout strategy in terms of both grouping and networking, hitting the different versions and so on. So this is super crucial for the success of the business and something we need to solve. Another thing is integration test. We all know that. We don't want to manually spend time going into a staging environment and swiping profiles and clicking buttons. We want this to be automated so we feel safe. These are two super important points of the business. We need to solve them either now or at least very soon in the future for this business to become a success, for us to actually be able to scale this. And this is when you realize you need a platform. You need some kind of strong foundation for your infrastructure that supports these upcoming business needs, something that actually lets you expand the tool set as your company grows. And then you take a look at this and be like, okay, sure, I can probably solve these problems using these tools, but is this really what I want to do? I can probably cook up something that is super tightly coupled to this cloud provider, and sure, I can make it work, but whatever I come up with, I cannot reuse that anywhere else probably. It's difficult to find people online that have actually solved exactly the same problems with the same tool stack and so on. And this is especially painful when you're someone like me that like I can solve these using CNCF products, but I'm constantly being held back by this choice of, for example, Fargate. So the choice comes up is, of course, do we want to keep digging deeper into the AWS ecosystem, or do we want to switch to Kubernetes? And since you read the description of this talk, you can probably guess that we switched to Kubernetes. So we went from AWS Fargate to Kubernetes, and more on that later, but for now, I'll hand it back over to Sander.
Thank you. All right, so let's talk about Green.ai. So let me try to set the stage first. Green.ai is an energy trading and energy asset management company. That means that our two primary businesses are algorithmic energy trading and balancing energy assets for clients. I assume none of you know anything about the energy trading industry. Neither did I when I started, but it's a very old industry, which means that we have to interact with lots of external systems, and all these systems are some combination of old, weird, and legacy. And they constantly change. So, of course, we need to be very flexible on our end to accommodate all these systems. Also, almost everything we do is machine-to-machine systems. So there's very little room for error, usually none. Errors are very expensive, so we must also be very precise. Also, we're a startup, so we need to be able to adapt and iterate quickly. And we're a small team, so we have limited resources to do so. In my section, I'll tell you about how we built the right platform with Kubernetes, and then how we built meaningful abstractions on top of it. But before we build the right platform, let's just take a look at how Green.ai looked when I joined. I was employee number 7. They've been working for a year and a half, and we already had trouble. So this journey starts as another classic startup journey to the cloud, and they were building a platform. Let me explain. So if you don't think you're building a platform, you're building a platform, right? Because all of the technologies that you choose and the processes that you create around them, this becomes your platform, but not in a structured or intentional way, right? And I like to refer to this as an implicit or emerging platform. So our emerging platform looked like this. These were the 4 main technologies we were using on AWS. So we had some EC2 Linux VMs, had some serverless functions with Lambda, and some serverless containers. I believe this was primarily ECS. I think we had a couple of Fargates also. And we had this Amplify serverless front-end thing, which meant that we had 4 different ways of doing everything. So if I was gonna roll out a new version of the EC2 deployments, that meant going into the web console, manually configuring a VM, SSHing into it, cloning some Git repositories, and praying that all of that still worked. Updating the Lambdas was done with this Zappa tool. Could you guys raise your hands? Like, has anyone used Zappa in here? I didn't think so. No shade to the Zappa guys, right? At least the Docker stack was relatively known, some Docker, some ECR, some AWS CLI, and I still honestly have no idea how the Amplify thing works. So because none of these technologies solved our problems, right, we kept adding more technologies as our needs changed. And this quickly became very painful, right? It created a lot of overhead because suddenly we had 4 different ways of doing everything. We had 4 different ways of developing applications, 4 different ways of delivering applications, 4 different ways of operating applications, 4 different ways of observing applications, and so on, right? This also meant that we had no structured approach to infrastructure or operations. And of course, everything was created as ClickOps. You don't know what ClickOps is. It's when you open the web console of your favorite cloud provider and you click on all the buttons and they create things and it's great. But in 3 months, something breaks and you don't know what was created, when, how, by whom, or how to fix it. So in other words, we had lots of complexity. So we took a step back, we looked at it, we reflected, and we decided it is time to take a structured approach to delivering and operating our software. In other words, we need a platform. Great! How do we build a platform? Well, we took the idea of the thinnest viable platform, or the TVP, from Team Topologies. It vaguely paraphrases down to what is the smallest platform we can build that actually solves our problems today. And in order to figure out the answer to that question, we asked ourselves these 2 questions, which were, what do we need right now to solve our problems? What are the requirements for our thinnest viable platform? And then essentially, what is the rest? What can we live with doing manually for now? And then we'll automate it later when we have the resources to do so. Right? And answering these two questions, let us define the requirements for our thinnest viable platform. So as follows: must have an extendable control plane, right? So we can automate things today. We can also automate weird things we don't know we need to automate tomorrow and the day after that. We must have single panes of glass, so we have one way of controlling our applications, one way of operating our applications, one way of observing our applications, so on. We must be able to create paved roads. This is a metaphor for creating streamlined processes for doing things, like creating a Helm chart to template and deploy your Kubernetes services. And everything must be as code. Also, must use mature and boring technologies and must be cheap in innovation tokens. There is only one technology that fulfills all these requirements, and it is, of course, Kubernetes. Great, now you've settled on Kubernetes. How do you actually build a platform, right? So we were on AWS, so we chose EKS, which is their managed Kubernetes offering. We try to run as many things in Kubernetes as possible, so all of our workloads run in Kubernetes, but we also use controllers in Kubernetes to control things outside of Kubernetes, like DNS, load balancers, persistent storage, that kind of thing. And then, of course, not everything can run in Kubernetes for one reason or another. So for the rest, we use OpenTofu. We can use some other boring technology like Terraform or whatever you like to do the rest. So we were 2 people working on the thinnest viable platform, more or less full time, and we got our first service in production in 4 weeks. We were able to do this because we set a very small and limited initial scope, and it achieved our goal of having exactly one way of doing things. We had one way of developing applications, one way of delivering them, one way of operating them, one way of observing them, and so on. This is vaguely how our platform looks today. It's pretty boring, and that's the point, right? So great, we're done. We have achieved platform. Now what? Well, now we need to use our platform, right? We need to create meaningful abstractions. Okay, cool. What's a meaningful abstraction? Well, I would define it as something that makes it easier to solve business problems in your very specific context by surfacing the right complexity. In other words, it's being very specific about the activities that provide value for the business and how to enable them. Okay, so let's look at how to create abstractions in a startup. Well, the most important thing is that you start as simple as possible, right? Whatever thing you're trying to build, whatever abstraction you want to make, set the smallest possible scope you can for that, right? And then as you figure out what your needs actually are, then you add more features to it when you need them, right? For example, if you're making a Helm chart to template your services, start out by templating the 10 keys you're actually going to change. Leave the rest with sane defaults or some hard-coded values that make sense in your organization, right? In other words, be very aware of trying to be too generic too soon, right? Instead, be very specific to what your needs are and how to enable them. And then as your abstractions and your platform matures, you will see patterns emerge, and then you build for those patterns. Also very important, don't be afraid to initially do things very ugly, very manual, right? It's okay. It's all about iterating, but you must iterate, right? So it's okay that your version 0 of your Helm chart is filled with hard-coded values all over the place, right? As long as you get started and you get out there and you create value, and then you improve it, you iterate on it, right? So some examples of meaningful abstractions in Greeting.ai. Users in this case are my colleagues, the platform users, developers and data scientists, that they on their own can deploy new trading algorithms, deploy and maintain data scrapers, expose frontends and APIs, that they on their own can answer questions like, is my service deployed and working? Like, what version is it running? Did my scheduled workflow succeed? What were the log output? And so on, right? And while none of the examples on the previous slide are particularly interesting or unique in and of themselves, there's lots of details, lots of complexity that goes into realizing them in exactly our Green.ai context, right? And realizing that is what makes them valuable and what makes them meaningful abstractions to us. Okay, cool. So let's see it in practice. Here's some YAML. This is a Helm chart. Please don't read the code. That's not the point. This is just to prove to you that it exists. So this is sort of an abstraction implemented as a Helm chart. I like to refer to this as a platform interface. This is where the actual surfacing the complexity happens, right? This is where the complexity the user cares about, like what container images is running, what DNS name does it get, those kinds of things. and the things the platform cares about, like how many resources should be allocated to your workload. And this is a Helm chart. Helm charts are ugly, and that's fine, right? Because they solve the problem, and they're very, very boring technology. Another nice thing about platform interfaces is that they make it easy to iterate on them. For example, we started out using vanilla Kubernetes cron jobs. Later, we decided to adopt Argo workflows. This was all handled in the platform layer. And from the user's perspective, switching from cron jobs to Argo workflows was as simple as exchanging these two keys in their Helm values. That was super nice. So in summary, create meaningful abstractions, focus on what matters, which is the business, create platform interfaces, standardize and streamline where it matters, start small and iterate, but you must iterate. I'll hand it back over to Dag, who'll tell us about something we all care about.
Thank you. So, what do we all care about? And here the answer is, of course, money. We all care about money. And especially when you work in a startup, you want to become profitable as quickly as possible before you run out of money. And one way of saving money is to sometimes switch to another vendor, switch to another cloud provider. And we have to remember that these cloud providers, they're in constant competition between them. So that means you get different kind of offers, you're getting different kind of discounts, credit packages, and all this kind of stuff. So sometimes it can be beneficial to switch. And that is what we did at Double. We decided to swap from AWS to Azure with the main goal of saving money. Many companies, they talk about they want to be cloud agnostic, and that means they can just switch back and forth between clouds and so on, but most companies never really do that, right? So I'll now show you how we did that with Double. Here is a highly simplified overview of our Kubernetes cluster. We have some Cloudflare pointing some traffic into our Kubernetes cluster, and then we're using various tools on AWS. We're using Lambda and SageMaker for machine learning. We're using Elasticache for caching, S3 for storage, and Secret Manager for secrets. We could, of course, try to move this to Azure just by copy-pasting the cluster over and then finding copies of all of the AWS products inside Azure. But that, I would argue that's a rather risky strategy because it can be difficult to actually find like identical replacements inside Azure. So you're not sure if it's actually going to behave the same if you try to copy it over. So another strategy is to see, okay, how many of these products can actually move into Kubernetes, making this transition easier? So we replaced Lambda and SageMaker with Argo workflows and Carpenter. Argo workflows for orchestrating the whole thing, and then Carpenter for spinning up these huge machine learning nodes. And then we replaced Elasticache with a Redis cluster. And that meant that now we have less dependencies on AWS specifically. We decided to keep the S3 bucket and Secret Manager on the cloud provider because it's very easy to find great replacements for that in all the other cloud providers. And now there's this looks better on my machine. I blame your Linux computer here for showing this. Anyway, it's supposed to say that these load balancers, they are burning a lot of money. These load balancers are kind of costly, or at least you realize that when you are in a startup. So if you can somehow manage to remove these load balancers, well, then in that case, you're saving money. And that's what we tried to do at Double. We tried out Cloudflare or Cloudflare D, however you want to pronounce that. So what these containers do is that whenever you start them up, they make a tunnel between the container itself and Cloudflare's global network, and that way you can route traffic from your domain on Cloudflare directly into the cluster through these tunnels. And with a little bit of help of an Nginx container next to it, you can then spread that out into the rest of the cluster. And it even works with external DNS, automatic creating your DNS record and so on. When someone from the team pitched this idea to me that we should use this instead of the official load balancers, I thought like that's probably crazy. I've never heard anyone ever do that not using the official load balancers. But we tried it out and I was so surprised how well it worked. It basically just worked right out the box, and I was very impressed with it. So this is just free advertisement for Cloudflare. Anyway, and this is very important for my next slide here, because that meant that now where we have things running on AWS, we could simply just go into Azure and say, hey, give me basically a default cluster with basic settings. And then we install Argo CD on it, and Argo CD then points to the right folder and installs the rest of our components automatically. And it also installs those Cloudflare resources, and that one just authenticated automatically to Cloudflare servers, meaning that our domain and routing and so on worked right out the box. So that was a very pleasant experience. And now the rest was hooking up this cluster to the rest of the cluster providers, products on the cloud provider, and in this case we replaced Secret Manager with Key Vault and S3 with blob storage. And this is actually where most of the pain came from, because you have to authenticate, and that is not the same on all cloud providers and so on. But imagine how painful this whole process would have been if we were still using like this Fargate, Lambda, SageMaker setup thing. We would basically have to recreate the entire thing in Azure if we wanted to. Here we could at least reuse most of it. And with that said, let's wrap this talk up. So the main takeaways from this talk is that, first of all, your business is complex, and developing software is also complex. And even though you think your business right now maybe is not that complex, that complexity is going to add up very quickly, and it's going to sneak up on you way faster than you may think. So it's important that you pick a platform, a tooling that actually supports this future complexity as your company grows. And don't get me wrong, Kubernetes is complex. Kubernetes is complex for everyone. But my point is that whatever other solution you're considering, that one is also complex. Like, you cannot get around this complexity. Because Kubernetes is not complex because it wants to be. It's complex because it needs to be. Like, you have a lot of cool ideas, advanced things you want to do that requires cool, complex feature set of the tool you're using, and that requires complex syntax and configuration and so on. And if you end up with that anyway, why are you not picking Kubernetes instead of some niche product from one of the cloud providers? Kubernetes is a boring technology. It's well known, it's been around for 10 years now, and it's easy to find documentation, easy to find other people that probably have seen the same issues as you have. It's much easier to hire for, and it's a boring technology. And it comes with a nice benefit of you actually being able to switch cloud provider, as we demonstrated here, which can become beneficial in the future for you. Your choices have consequences, like picking the right tool have very strong implications on your overall architecture. And the way me and Sanders sees this is basically these serverless solutions, they're more like gateway drugs that are trying to lead you down a path that you probably do not want to take. So as we see it, Kubernetes is really the only choice. You should start simple. You should start building the thinnest viable platform. Don't overcomplicate anything. Start with some simple abstractions that make sense right now, and don't over-engineer it for the future. Start simple, iterate over it from there. And as we see it, like, if you plan to build a business empire, why not start on Kubernetes and skip the pain of migrating to it later? And with that said, thank you very much.